Question number 20. Find the oblique asymptote and sketch the graph of the rational function. So you're going to take negative x cubed plus 2x squared plus 4x minus 1 and divide it by the denominator, x squared plus 2x minus 5. Now you're thinking of a number that multiplies by x squared to give you negative x cubed, so it's going to be x, negative x. So it gives me negative x cubed, gives me minus 2x squared, and it gives me plus 5x. I'm going to go through, change all the signs, and I'm going to add straight down. So those cancel out, give me 4x squared, it gives me minus x minus 1. Now I need a number that multiplies by x squared to give me 4x squared, so it's plus 4. That'll be 4x squared plus 8x minus 20. Change signs, add straight down, so I get negative 9x plus 19. Now because that x has a power of 1 and this one has a power of 2 up here, I know that's a remainder. So all I'm interested in for the slant or the oblique asymptote is the quotient. So y equals negative x plus 4. Now looking at these over here, I know that the slope is negative. So I'm looking at the slant asymptotes. So slant asymptotes are that line there, that one there, that one there, and that one there. Okay, those are the slant asymptotes. I know the slope's negative, so it can't be that one, and it can't be that one, because those slopes are positive. So I'm going to look at this one here, B and D, and I'm going to try to look at, I'm going to have to blow them up, but whichever one of those slant asymptotes crosses at positive 4 would be the one that on the y-axis, that's the y-intercept, whichever one crosses at 4 would be the one I choose. With this one, okay, it's a rational inequality, so we've got to be greater than 0. So that means at the end we're looking for positive results. We're going to factor it, so factors the y, or w minus 4, w plus 3, and w minus 2 on the bottom. Those give me then the zeros of negative 4, or positive 4, negative 3, and positive 10. I'm going to put an open dot at 10 just to remind myself that I can't use that because it's in the denominator. And now I'm just going to go find signs. So if I choose a number to the left of negative 3, like negative 10, it'll be negative, 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 so the total is negative. In the middle here, 0 is in the middle, so I choose 0. So that's going to be negative, positive, negative, so that's a positive. Now I'm going to check a number like 6. So 6 minus 4 is positive, 6 plus 3 is positive, 6 minus 10 is negative, so total is negative. And then a number like 12. 12 minus 4 is positive, 12 plus 3 is positive, 12 minus 10 is positive, so my total is positive. Again, at the beginning we wanted to say we're looking for positive values, so that's there and there. And we can be greater than or equal to, so equal to at 3, negative 3, equal to at 4, can't be equal at 10 because that's the denominator. So graphically those are the answers. I'm going to write that as negative 3 to 4, union 10 to infinity. This one they want to know when is the curve equal to the line x plus 3. So they're equal right there where they cross, and that's an x value of 0. All right, now they want to know when is the curve below the line. So here's the curve. Let's see if I can highlight this. They want to know when is that curve below that line. Okay, well the yellow is below the green, starting at 0 and going to the right. So 0 to infinity. So right there. They want to know, and it's below or equal to, so that's why we started at 0 and include 0. Now they want to know when is the curve, when is the yellow greater than the line. So when is the yellow above the green? Well, the yellow is above the green over here, so it's these x values. So some people might say, well, I'm going to go from negative infinity up to 0. But the yellow doesn't exist all the way at negative infinity. The yellow only exists at negative 9. So I go negative 9 to 0, and I'm going to include negative 9 and we'll include 0 because we've got that equality there. This one, we're going to cube both sides to get rid of that 1/3. So when I cube it, I get x squared plus 2x. Cube 2, I get 8. So now I have x squared plus 2x minus 8 equals 0. That's going to be x minus 2. X plus 4 equals 0. X is 2. X is negative 4. I just got to make sure that when I plug back in, I get true statements. So when I plug in 2, I get 4 plus 4 is 8. The cube root of 8 is 2, so that works. When I plug negative 4 in, I get 16 plus negative 8, which is 8 again. 8 cube root of 8 is 2, so negative 4 works. This one here, you gotta get rid of this outside radical first. So I'm gonna square both sides. So when I square both sides, you get 61x plus 13 equals 4x plus 2. Now I still have this square root, so I need to square again. So 61x plus 13 equals, square this side, so 16x plus, or sorry, 16x squared plus 16x plus 4. I'm going to go ahead and move when I move everything over, I'm going to get 0 over here, it'll be 16x squared minus 45x, and then minus 9. Using my A times C method, when I take 16 times negative 9, 16 times negative 9 gives me negative 144. Now I'm thinking about two numbers that multiply together give me 144 and add up to negative 45. And those two numbers are 3 and 48, and the 48 has to be negative. So I'm going to have 16x squared minus 48x plus 3x minus 9 equals 0. Factor out of 16 out of 16x out of the front 2. It gives me x minus 3. Factor out of 3 out of the back gives me x minus 3. So my factors are 16x plus 3 and x minus 3. This is all equal to 0. So it's going to give me x to be 3, and it gives me x to be negative 3/16. When I solve those, and both of those end up being solutions here for this problem. To answer this question, you could have graphed it and seen when is the left-hand side above the line y equals negative 1. All right, and that's going to be, I believe if you were to graph it, you're going to find it's option A, it's between negative 10 and 11. But if I'm going to do it by hand, I need to isolate one side of one radical. Okay, but before we do that, remember when we had radical inequalities, we first had to decide what value, we had to decide domain values basically. So what values x could be here. So we say x plus 10 had to be greater than 0 or equal to 0. And that's going to say x is greater than or equal to negative 10. But then at the same time, because we're using the same x value, that 11 minus x had to be greater than or equal to 0 as well. So it says x has to be less than or equal to 11. So I write that on my number line. Negative 10 and 11. And on my number line, x can only be those values. Okay, between those. Now, we might be able to narrow it down between those, and that's what the next algebra is going to do, is see if we can narrow down. Maybe it's only between negative 8 and 11, or maybe it's only between negative 10 and 6, or something like that. So we got to do further algebra here to find some more points up here. So what we do is we solve the accompanying equation. So I'm going to take radical x plus 10 equal to negative 1 minus the square root of 11 minus x. I'm going to square both sides to get rid of this square root, so it gives me x plus 10 on the left. Now when I square the right hand side, it's going to be negative 1 times negative 1, which is 1. It'll be these two things multiplied together, so it gives me a positive 1 and then this square root, but then I double that, so it's going to be a positive 2 and that square root of 11 minus x. And then last times last will give me plus 11 minus x. So when I start moving, I want to isolate this radical now. I'm going to move the x over, so it gives me 2x. I'm going to move this 12 over, so it gives me minus 2 is equal to 2, 11 minus x. Divide everything by 2, it gives me x minus 1 is equal to square root of 11 minus x. I'll now square both sides, so it gives me x squared minus 2x plus 1 over here, and 11 minus x over there. I'll solve this for 0 then, or set this equal to 0, so I'll add x to both sides, so it gives me x squared minus x, and I'll subtract 11 from both sides, it gives me minus 10. Now, I'm going to have to use the quadratic formula to factor that, okay? So give me 1 second, and I'll do that, and I'll come back with that factored form. So once I use the quadratic formula, it provides me these two results. So I'm going to change those to decimals just to make things a little bit easier. And when I change those to decimals, I'm going to get approximately negative 2.70, and here I get positive 3.70. So I'm going to put those up here. Negative 2.7 and then 3.7. So now what all I have to do is I broke up into 3 intervals. I got to try a value in each one of these intervals back into the original inequality to see if I get true or false statements. So in this interval here, we got a number like negative 5. So if I put negative 5 in, I'll get radical 5 back. If I put negative 5 in here, I'll get radical 16 back. If I add those together, I'm going to get a number bigger than negative 1. So that's a true statement. Now in this interval here, 0 exists, so I'm going to plug 0 in. I plug 0 in, I get radical 10. Here I get radical 11. If I add those together, I will get something bigger than negative 1. So that's true as well. And now I'm going to try a number between 3.7 and 11. So I'm going to try, 10. If I plug 10 in, I get 20, square root of that. Plug 10 in here, I get square root of 1. If I add those together, that's something bigger than a negative number, so that's true as well. So I got true values in there. Sometimes you might get a false value in one of these intervals. It's just the nature of the problem. Here, it's true everywhere, so my end result is negative 10 to 11. Okay. Now, because this was greater than, I can't be equal to there, and I can't be equal to there. All right, because that will actually give me negative 1, and I don't want that. So I'm going to open parentheses, and obviously you see everybody had choices here, and the way they're all set up is none of them are going to have brackets. So if you miss that part, you should still see the answer that you found over here.